Okay, so semua Assalamualaikum and good morning, right? Okay, so today we discuss about improper integral. Okay, so improper integral is an integration which involving infinity, okay, ataupun involve discontinuous limit. Okay, alright, so look at this note. Okay, so improper integral. So improper integral is any integration that involving infinite interval, okay, and infinite discontinuities. Okay, so it is called it as an improper integral. So maknanya dekat sini kalau kita ada integration yang melibatkan infinite interval. So infinite intervals like infinity, okay, to A. So A is a point So infinity to A ataupun negative infinity to A, sorry. So kalau kita ada integral which involving the limit here is a negative infinity to A. So A is any real number. Okay. Ataupun kita ada from A to positive infinity. So ini kita panggil sebagai infinite interval. So maknanya dekat sini kalau kita ada integration yang melibatkan infinite interval, so kita panggil dia sebagai improper integral. Okay. Yang discontinuities kalau kita ada limit yang ada gap dekat situ ataupun yang ada berkaitan dengan asymptote. Okay, for example, let's say we have limit A to B. Okay, so where A does not include in X values ataupun tidak termasuk dalam nilai-nilai X. So ini kita panggil sebagai discontinuities. Alright. Itu pun kita panggil sebagai improper integral. Okay, so in improper integral, we have three types. The first type, which is integral over infinite interval of integration. Okay, in example, we have this integral, which is integral f of x dx, where x is 1 to infinity. So this is means that the interval of x here is 1 and it goes to infinity. Okay, and next, if we have this integral, we also call it as improper integration ataupun improper integral because the interval involving negative infinity to 3. Okay, negative infinity to 3 sebab dia ada melibatkan infinity kat sini. So kita panggil sebagai infinite interval, and the integration we call it as improper integral. And the next example, if we have interval involving negative infinity to infinity. So, ini memanglah improper integral. So, semua ni kita panggil sebagai improper integral. Okay. And next, in type 2, integrand whose integrands have infinite discontinuities in the interval of integration. Okay, so yang ini yang melibatkan discontinuity. So, apa maksud discontinuity? So, kita ambil satu contoh. Let's say we have this integration, which is integral 1 over x minus 2 respect to s, where the interval of x for this one is 1 to 5. So, ini kita boleh katakan interval of x ataupun the values of x, it is 1 to 5. Okay, 1 ke 5. Alright, so next we need to check this function. Ini adalah function kita. Okay, so ini kita nak check discontinuity dia. Adakah untuk function 1 over x minus 2 is continuous in this interval? Adakah dia continuous tu maksudnya there is no gap. So kalau you plot point, you akan dapat smooth curve lah ataupun smooth graph. For example, kalau kita point dekat sini, and then kita point dekat sini, kita point dekat sini. So, kita akan dapat smooth line ataupun smooth graph. Okay. Ini kita panggil sebagai continuous. Kalau discontinuous, bila dia pada point, katakan point di sini, point B, dia ada cap dekat sini. So, maknanya bila you masukkan nilai B ke dalam X, so this function is undefined. Okay, this function is undefined. So we can say that x is not equal to b. Ataupun kita boleh katakan the values of x does not include b. So bila you masukkan nilai x, nilai b ke dalam function, dia ada gap dekat situ. Ataupun dia ada, you tak dapat jawapan lah. So kita katakan this function is discontinuous at x equals to b. So yang lain ini adalah semua nilai-nilai x. So dia ada gap dekat situ. Itu kita panggil sebagai discontinuity. So ini yang dimaksudkan discontinuity. Okay, so back to this example. So based on this integral, we identified that the interval here is 1 to 5. Okay, 1 to 5. So next we need to check for this function, which is 1 over x minus 2. So the values of x dekat sini, mudah untuk kita tengok sini, 1 to 5. So which is x is greater than 1 and less than 5. Okay, so interval dia. So nak check dekat sini, kita dah tahu dah untuk denominator dekat bawah ni tak boleh kosong. It cannot be equal to 0. Okay, so that we can say that x minus 2 cannot be equal to 0. Tak boleh sama juga dengan kosong. So based on this, we identified that x does not equivalent with 2. So maksudnya x tidak boleh 2. Kalau you masukkan nilai 2 ke dalam function ni, you akan dapat 1 over 0. So 1 over 0 is undefined. Jelas kat situ? Faham Faham? Ada soalan setakat ni? Yang ni you kena betul-betul faham. Kalau tak, nanti you tak faham.
Faham.
Faham Okay, bagus. So maknanya dekat sini, untuk function 1 over x minus 2, s does not equal to 0. So if s equal to 0, then this function is undefined. Okay, so this means that it has a gap at x equals to 2. So pada 2 tu dia ada gap. So bila kita tengok pada interval yang ini, 1 to 5, x 1 to 5, it is include 2. So dalam interval ni, terkandunglah nilai 2 dekat situ, which is the values of s in between 1 to 5. So 1, 2, 3, 4, 5. So 2 termasuk dalam interval yang ini. Okay, so based on our discussion about this function, okay, so as it does not equal to 2, so here we can say that this function, this function is discontinuous at x equals to 2. So maksudnya pada nilai x sama juga dengan 2, dia ada gap. Itu kita panggil sebagai infinite discontinuity. Infinite discontinuity. So maksudnya dekat sini nilai x, the values of x must be greater than or equal to 1 and less than 2, and then union with x is greater than 2 and less than or equal to 5. Okay, so instead we need to split into 2 integral, then we need to solve it. Okay, faham ini kita panggil sebagai infinite discontinuity. Samalah juga dengan ni. For this example, we have this function. So this function is about f of x. It is equal to 1 over x. So we understood that x cannot be equal to 0. Okay, so based on this interval yang ini adalah, so x in between negative 1 to 3. Okay, so between negative 1 to 3, it has 0. Ada kosong dekat situ. Okay. Jadi apa you kena buat? You need to split off into 2 integral. Then we need to solve it. Okay. Right, so ini type 2. In the type 3, integrals whose integrands have infinite discontinuities over infinite interval of integration. So yang ini untuk type 3. Okay. So type 3, the integral whose integrand have infinite discontinuities. Dia ada discontinuities kat situ. Okay. And then it is involving infinity also. Untuk yang macam ni. Okay. Right. So for this example, yang ini, kita ambil contoh yang pertama ni. Kenapa kita katakan dia adalah type 3, which is integral whose integrand have infinite discontinuities. Okay. So we have this function, f of x equals to 1 over third x. Okay. So we know that for square root of x cannot be equal to negative. The values of x must be greater than 0. Mesti lebih besar daripada kosong ataupun sama juga dengan kosong untuk square root punya rule. Okay, so since square root of x is denominator, so here we can say that for x, untuk x kat sini, for x value, it must be always greater than 0. lebih besar daripada kosong. So, maksudnya the values of x must be greater than 0. So, nilai yang paling kecil untuk x pun 0 point something lah. Tak boleh kosong. Kalau kosong, this function is undefined. Kalau negative, if x is negative, it is also undefined. Okay. Alright, so based on this example, the interval of x is 0 to infinity. Okay, so kat sini ada dua perkara. Satu, discontinuous. Okay, discontinuous, which is x is must be greater than 0. And the other one here is infinity. Okay, infinity. Siapa yang nak kena buat lah, you kena pecahkan kepada dua bahagian juga, tiga bahagian. Okay, dua atau tiga, lebih kurang macam tu. Which is the values of x is 0. And we need to take any number. Okay, let's say we take 1 union with x greater than 1 and goes to infinity. Macam tu. Alright, ini masuk type 3 lah. Dia ada discontinuous and juga that end. It also has infinity. Okay. Alright, so number yang kedua ni, okay, which is we have this function 1 over x plus 1, and the interval is negative infinity to infinity. So it is obviously include the discontinuity in this interval. Alright, so ini adalah type yang ketiga. Okay, ada soalan tak untuk improper integral? Yang ini you penting untuk you tahu jenis-jenis improper integral. Sebab nanti bila you nak selesaikan masalah yang melibatkan improper integral, you tahu macam mana you nak cater the problem. Okay, macam mana you nak handle the problem, which type. So, sebab every type, cara dia berbeza. Okay, faham Alright, so kalau faham, now look at this definition. Okay, so definition 3.1, it is about improper integral in type 1a. Okay, type 1a. So the improper integral of f over a to infinity. Okay, so this is the interval a to infinity is defined as integral f of x respect to x, and the interval of x is a to infinity. It is equivalent with limit b approach to positive infinity for the integral f of x where x is a to b. Okay, so dekat sini, since we have infinity here, then we need to put limit. Okay, so we take b approaching to infinity. So that's why we have a limit b approaching to infinity for this integral. Okay, so ini adalah definition. Right, so bila you nak selesaikan masalah ni, you kena define ataupun you kena give, you have to give the definition about the improper integral. Alright, so ini sangat penting. Okay, so based on this, if limit exists, then the improper integral converge. If limit exists, the improper integral converge. The limit is the value of the integral. So else, if the limit does not exist, then the improper integral diverge. So maknanya dekat sini, you kena cari limit dia. So kalau limit dia exist ataupun dia ada nilai, so kita katakan the limit is exist, then the improper integral converge. So if the limit does not exist, let's say we have infinity or negative infinity. So we can say that the limit does not exist, then the improper integral diverge. Okay, so again, after we solve for this improper integral, okay, we need to find the limit, right? So if the limit exists, then the improper integral converge. Okay, so macam mana nak tahu limit dia exist ataupun tidak? Untuk limit exist, dia akan ada nilai lah. It can be any value, alright? So we can say that the limit exists, therefore the improper integral converge. If the limit, it is approaching to infinity or negative infinity, we state it as the limit does not exist, then the improper integral diverge. Okay, faham ya? So, point yang penting kat sini adalah yang inilah definition. So, maksudnya untuk improper integral, you need to find the limit. Alright. Any question for this definition? Ada soalan? Tak
Madam,
ada. Ya, apa dia?
kan kalau yang infinity tu dia kira does not exist kan?
Ya.
Kalau yang exist tu macam mana? Kalau
Kalau
yang
yang
alpha beta tu,
alpha,
yang
beta,
A, B tu,
ya.
dia kira exist ke does not exist?
Okay. Alright. Okay, thank you for the question. Alright, so untuk limit axis, okay, so in order to determine whether the limit exists or does not exist, first we need to solve for this integral. You kena selesaikan integral yang ini. So how to solve the improper integral? We need to use this definition where we need to find the limit. Okay, since the interval for this integral ataupun for this function is a to infinity, so maknanya dia punya interval adalah a to infinity. So the values of infinity we do not know. Apa nilai untuk infinity? Kita tak tahu. Okay, jadi kita boleh jadi the meaning of this interval means that the values of x is approaching to infinity. So kalau you nak tengok dia punya value dia bergerak, okay, so this one is a. Okay, so the values of x is from a and it goes to infinity. Dia pergi ke nilai dia meningkat ataupun nilai dia sentiasa bergerak sehingga ke dia pergi ke infinity lah. So maksudnya there is no boundary. Okay. Alright, tu satu. Yang kedua, macam mana kita nak selesaikan masalah yang melibatkan infinity macam ni? How to solve it? Okay. So, we find the solution where we need to find the limit. So, kenapa kita letakkan limit dekat sini? Sebab nilai x yang paling minimum bagi x adalah a. Okay. So, bila you nak selesaikan untuk interval ataupun untuk integral, you need to have a lower limit and the upper limit. So the problem here is we do not know what the upper limit. Kita tak tahu sebab dia tak ada limit. Sebab dia pergi kepada infinity. There is no limit. It goes beyond. Okay, dia pergi ke infinity. Okay, so that is why we take limit, which is limit b approach to positive infinity. So b, it is represent for x. Begitu. Dia adalah represent ataupun mewakili nilai-nilai x. So maknanya dekat sini the values of x it is approaching to infinity. So kita letakkan b dekat sini, unknown b. Alright. Okay, itu yang pertama. Itu that is how we solve the problem which involving improper integral. Second, after you find limit, if we have any value, okay, ataupun you dapat apa saja nilai, kita katakan the limit exists. Okay, let's say after we solve for this problem, which is limit yang ini kita selesaikan. You selesaikan for this one, limit b approach to infinity for a to b for this function. Okay, it is equivalent L. L is any number lah, any value. So ini kita katakan the limit exists. So this one limit exists. Okay. Right, so bila limit exists, we can say that the improper integral converge. Okay, katakanlah lepas you selesaikan problem ni, limit b approach to infinity for this integral, and we have infinity. Okay, so bila you dapat infinity, so maksudnya there is no limit. Dia tak ada limit. Sebab dia tak ada nilai dekat situ. Tak ada nilai yang untuk kita converge ataupun tak ada nilai untuk kita tumpu. Alright, so bila you dapat infinity, so ini kita katakan sebagai limit does not exist. Does not exist means that there is no limit because we have infinity or negative infinity. Okay. Alright. So since we have the limit does not exist, then we can say that the improper integral diverge. Faham? Ada soalan?
Faham.
Okay. Alright. So in other words, we need to solve for this improper integral then we can identify whether the limit exists or the limit does not exist. Okay,
Madam,
right? Yes.
kalau macam untuk limit B tu kita tentukan ke ataupun kita kena solve baru dapat nilai B?
Yang ini untuk B ni. So, okay, so untuk B ni, actually you can take any unknown. Okay, any unknown instead of B. Alright. So untuk yang ini, sama ada kita nak tentukan ataupun tidak. This one, ini adalah this is the definition for this improper integral. So maknanya dekat sini kita sendiri yang tentukan sama ada dia B ataupun C ataupun apa. As long as you understand that the B here is represent for values of X. Okay. So ini pun mewakili nilai X juga. So bila you nampak dekat sini, untuk integral yang ada limit macam ni, you understood A to infinity is an interval of X. Dia adalah nilai-nilai X. Okay, so X, apakah nilai-nilai X dekat sini? Adalah X equals to A and it goes to infinity. Alright, so bila you nak cari dia punya nilai, kena ingat untuk definite integral, if we have the limit, okay, kita ada boundaries ataupun ada limit, you akan masukkan nilai tersebut kan? And then you akan dapat nilai dia, which is the upper limit minus with lower limit. So nilai yang you masukkan tu adalah nilai X. Okay, so nilai X minimum A and the maximum here is infinity. Right, so since infinity itu tiada nilai yang nyata, jadi kita letakkan dia sebagai limit. Kenapa limit? Sebab untuk nilai-nilai X ini, paling minimum dia adalah E. And the maximum it goes to infinity. Dia bergerak ke sebelah kanan. Which is the value is large and larger. Okay. Sebab tu kita letakkan limit dekat situ. Which is it is approaching to infinity. Maksudnya nilai X itu bergerak ke nombor yang lebih besar. Okay, itu maksudnya. Alright. Yes, am I answer your question?
Yes, madam.
Alright. Okay, ada lagi soalan? Tak ada Right, so kalau tak ada, kita example 1. Okay, so in this example, we need to determine whether the integral 1 over x, where x is 1 to infinity. So maksudnya dekat sini, interval bagi x adalah 1 to infinity. So here we need to determine whether this improper integral is convergent or divergent. So bear in mind, so if convergent means that the limit exists. Okay, so diverge means that limit does not exist. Okay. Alright, so since this integral involving infinite interval, so here we can say that this is about improper integral. Okay, so maknanya dekat sini, this integral, the limit ataupun the boundaries for x is x. It is 1 and goes to infinity. So this is the interval for this function. For this function 1 over x. So ini interval dia. So maknanya dia adalah nilai-nilai x lah. Alright. Okay. So as a solution, first step we need to test for the existence of infinite discontinuity. So untuk yang ini, untuk step 1, we need to test the discontinuity for this function. Apa function yang dimaksudkan adalah, so our function here is 1 over x. Okay, so 1 over x, so since x is denominator, so x cannot be equal to 0. Okay, so now x cannot be equal to 0. X can be any number except 0. Dia tak boleh kosong. Kalau kosong, this function is undefined. So ini yang akan menyebabkan the discontinuity. Okay, discontinuity. Ataupun dia, this function is discontinuous at x equals to 0. Alright. So next, you kena tengok dia punya interval. So interval untuk x dekat sini adalah, interval for x is, I buat macam ni. X, interval dia adalah 1 to infinity. So kalau you tengok interval dekat sini, kosong termasuk tak ke dalam interval yang ini? Nilai-nilai X termasuk tak dalam X? Zero. Tidak. Okay, good. So since dia tak termasuk dalam X, so we can say that X ataupun this function is continuous on the interval 1 to infinity. Right? So maksudnya dekat sini, kalau you masukkan nilai yang dalam interval X ni, okay, range X ni, dia akan sentiasa memberi kita nilai. You masuk 1, you akan dapat nilai. 1/1 is 1. So 1/2 is 1/2 and so on. Okay, so here we can say that this function, which is 1/x, is continuous on the interval 1 to infinity. Okay, so in example, 1/x defined for all x 1 to infinity. So define ni maknanya dia memberi kita nilai lah. So undefined adalah benda yang kita tak ada jawapan dia. Okay, so it is defined for all values of x where x is 1 to infinity. So here we can say that 1/x has no infinite discontinuity on the interval 1 to infinity. Jelas kat sini untuk step 1?
Jelas, madam.
Very good. Okay, good. Okay, so next step, we can solve the improper integral. Okay, so based on the definition, in order to solve for improper integral, we need to take the limit. Okay, so that integral 1/x, where x is 1 to infinity, it is equivalent with limit b approach to infinity for the integral 1/x, where x is 1 to b. So what is the value of b? The value of b is approaching to infinity. So kalau you nak form into a number line, so this is a x. So the minimum value for x is 1 kat sini. And the value of x is move to the infinity. Dia bergerak. So nilai dia bergerak kepada sebelah kanan. Which is number dia akan lebih besar. Okay, sebab tu kita letakkan B. Okay, so kenapa kita letak unknown B? Sebab kita unknown ni biasa kalau you letak ni menunjukkan kita apa? Kita just letak unknown tu means that we do not know the value of B. Macam itulah umpamanya begitu. Okay? Alright, so kita gantikan the maximum value of x is B, where B is approaching to infinity. Okay? Alright, so next we solve for this integral. So integral 1/x dx, it is equivalent with natural log of x. Okay, so kalau ada limit, we need to the upper limit minus with lower limit. Okay, so we solve for this integral. Then here we have natural log of x, where x is 1 to b. Okay, where since b approaching to infinity, so here we have natural log of b minus natural log of 1. Okay, so natural log of 1, it is 0. So natural of b approaching to infinity, you akan dapat apa dia? Infinity. Okay. So here, the improper integral, which is integral 1/x with the interval 1 to infinity, it is approaching to infinity. Okay. So the limit does not exist. Therefore, the limit ataupun therefore the improper integral diverge. Faham? Yang ini yang kadang-kadang you akan gunakan L'Hopital's rule, indeterminate power ataupun indeterminate difference ataupun indeterminate product kat sini. Alright, so maknanya dalam erti kata lain untuk improper integral, dia memang melibatkan limit. Alright? Faham?
Faham.
Okay, very good. Alright, so this is a theorem. If we have this improper integral, which is dx/x to the power of p, where x is 1 to infinity. So the values of x ataupun the interval of x is 1 to infinity. Okay. It is equivalent with 1/p minus 1. If p greater than 1, then the improper integral will be converged. So if p less than or equal to 1, so p is a power of x. So the improper integral will be diverged. Okay. So contoh dekat sini, let's say P, we have this improper integral 1 to infinity for dx over x to the power of 2, for example. Okay. Right. So bila kita selesaikan untuk improper integral, limit b approach to infinity for the integral dx over x to the power of 2 dx, where x is 1 to b. So what is a b? B is approaching to infinity. Okay. So first we solve for the integral dx over x squared. It is also equivalent with x to the power of negative 2 dx, and we will have negative 1 over x. Okay, 1 over x plus c. Okay, so hence, kita nak check betul tak theorem ni? Macam tu. Alright, so hence, limit b approach to infinity for the integral dx over x squared, where x is 1 to b, it is equivalent with limit b approach to infinity. Yang ni, answer dia, negative 1 over x. Yang tepi ni dia punya limit. So, the lower limit dia is 1 and the upper limit dia is b. Okay, so it is equivalent with limit b approach to infinity for negative 1 over b minus, you akan dapat plus 1 over 1. Okay, so the lower limit here is 1. So, you just masukkan nilai x. Lower limit x. Okay, so this one is the upper limit. Yang ni adalah lower limit. Okay, so you cari nilai dia. And then this one, 1 over 1, it is approaching to 1. So, the value of 1 over 1 is 1. Okay, so this one, negative 1 over infinity. B approach to infinity. Then we have negative. We have 1 over infinity for the limit. You dapat apa?
Negative infinity.
1 over infinity in the limit. 1 over 0, we have infinity. Right, 1 over infinity. Macam mana nak tahu 1 over infinity? Okay, so you just plug in your calculator. You can start B with the lower number yang kecil. So, you kena ingat B approaching to infinity. So, maksudnya nilai B itu semakin besar. Okay, so you plug in your calculator. Start with 1 over 2. And then you tengok 1 over 3. Tengok nombor dia makin besar ke makin kecil. The approach to apa? Approach to Z. Approach to 0. It is approaching to 0. Okay, so here 0 plus 1, we have 1. Kita akan dapat 1. So therefore, improper integral 1 to infinity for 1 over x to the power of 2 dx, it is equivalent with 1. Okay, so the limit exists. Therefore, the improper integral converge. Okay? Faham tak ni? Ada soalan. So it is proof. Okay, so based on this experiment, it is proven that for the improper integral for the power x 1 over x to the power of p, where p is greater than 1, then the limit is always converge. Okay, faham? Ada soalan tak ni?
Tak ada.
Medium.
Yes.
Kalau macam tadi kan medium guna x power of 2 kan. Kalau x power of 3 pun kita boleh guna kan?
X power of 3 pun boleh gunakan.
Okay.
As long as dia melibatkan infinite interval. Ini kita panggil sebagai infinite interval. Interval difahamkan. So what is an interval? Interval adalah range of x, nilai-nilai x. Range dia ada range dia minimum and maximum. So yang ini kita panggil sebagai infinite interval. Okay. So katakan you ada, I ambil contoh lain . Katakan kita ada the interval of x is A to B. A to B. So this one is a definite interval. Definite interval. Ini yang biasa kita selesaikan lah. Before this, we solve for definite integral, which is definite integral. That means we have definite interval. Okay. Tapi untuk topik yang ini, dia melibatkan infinite interval. So, macam mana nak selesaikan infinite interval? Sebab dia melibatkan infinity. Secondly, kita tak tahu apa dia punya upper limit. So, kalau you tahu lower limit, mudah. You just, kalau you tahu dia punya upper limit, mudah. You just minus between upper limit minus with lower limit. Yang macam kita buat sebelum ni untuk definite integral tu. Sebab kita ada definite interval. Tapi kalau untuk infinite interval, it's quite difficult to us to solve. So that is why we comes with this definition. Kita cari limit dia lah. It is logic because untuk infinity dekat sini, it is approaching, dia bergerak, dia menghampiri ataupun it goes to infinity. Dia pergi ke infinity. Okay, faham ya?
Faham.
Jelas? Faham Okay, so you kena faham dulu apa maksud infinite interval and definite interval. Alright, ada soalan tak untuk ni? Katakan kita ada 1 over x to the power of 3. Macam kawan kita tanya-tanya tadi. Okay, so based on this theorem, it says that if p, the power of x is greater than 1, the improper integral is always converge. Okay, so nak tahu betul ke tidak, sahih ke tidak, you boleh cuba selesaikan. Okay, so how to solve? Yang I buat ni, inilah cara untuk kita selesaikan. Okay, so for this example, I take a P equals to 2. Power dia adalah 2 kat sini kan. Nak tengok betul ke nak buktikan yang theorem ni benar. Okay, so I take x to the power of 2, 1 over x to the power of 2. So after we solve and we identified that it has a limit. Ni masuk limit. Even though you dapat kosong pun, kita kata limit exist. Selagi dia ada nilai lah. Zero is a value tau. Walaupun dia kosong. Okay. Alright. So, kita kata limit exist. Therefore, the improper integral is convergent. Okay. Any question? Ada soalan untuk example 1 ataupun untuk theorem? Tak ada
Tak ada.
Alright, good. So, kalau tak ada, kita example 2. Alright, so in this example, we need to evaluate the improper integral 1 minus x times exponent to the power of negative x with the interval 0 to infinity. Okay, so based on this improper integral, first we can identify the interval of x. So interval of x is 0 to infinity. Okay, so 0, I guna close bracket ni, maksudnya nilai x adalah kosong. Untuk infinity, we do not know the value of the upper limit. So, kita letakkan open bracket. Okay, so this is the notation for interval. Alright. Okay, so second, our function here is, the function kita adalah 1 minus x times exponent negative x. So this is our function. Alright. Okay, so here we have 2 steps. So before we solve for this improper integral, first we need to test the discontinuity. We need to test the discontinuity. Kita nak check. Okay, discontinuity ada tak? The discontinuous between this interval. Alright. Okay, so we have this function which is 1 minus x times exponent to the power of negative x. So it is also equivalent with 1 minus x over exponent of x. Okay, so ini adalah benda yang sama lah. So this one in the line, so this one in the right hand side, it is in the ratio form. Okay. Alright, so we check. So how to check? So since we have this function, which is f of x equals to 1 minus x over exponent of x. So as usual, since e of x, exponent of x is a denominator, okay, so e exponent of x does not equal to 0. Tak boleh kosong. Okay, tak boleh kosong. Alright, so how to find the values of x? Satu macam mana kita nak tahu nilai yang bukan x. Okay, so we can selesaikan x kat sini. So we take natural log left hand side and right hand side. Okay, so natural log exponent of x, we have x. So x does not equal to natural log 0. So natural log 0 is berapa? Natural log 0. Ln 0. Berapa? Max
Undefined.
error. Undefined. Okay, so it is undefined. Okay ni, undefined. Okay, so there is no x. There is no x element of real number. Okay, such that exponent of x equal to 0. Okay, so here we can say that 1 minus x times exponent negative x is continuous on the interval 1 to infinity. So maknanya dekat sini, the values of x, it can be any real number. Okay. Okay, x can be any real number. So means that kita masukkan apa-apa saja nilai. Okay. So the function is always defined. Termasuklah you masukkan nilai kosong. Exponent 0 will be 1. Macam tu. Alright. So kita boleh katakan this function is always continuous on this interval. Interval 0 to infinity. That means there is no issue about discontinuity ataupun discontinuous. Tak ada issue dekat situ. Alright. Okay, so next we solve the indefinite integral. So for this case, we use integration by parts. Okay, so solve for this integral 1 minus x times exponent negative x. So let u here is 1 minus x. And we differentiate respect to s on u. We have negative dx. And the rest is our dv. So dv here is exponent negative x. So we integrate both sides, then we will have v. So v is negative exponent negative x plus c. Okay, so you solve by using integration by parts. Integral u dv equal to uv minus integral of v du. So you masukkan, and then kita dapat jawapan yang ini. X exponent of x plus c. X exponent negative x plus c. Alright, so next we solve the improper integral. So based on the definition, the improper integral 1 minus x times exponent negative x dx with the interval 0 to infinity, it is equivalent with limit b approach to infinity for the integral 1 minus x times exponent negative x dx, and the interval is 0 to b. So what is a b? B is approaching to infinity. Okay. So you solve yang ini, we have x exponent negative x. It is also equivalent with x over exponent of x. Okay, so ada power negatif. So power negatif ni maksudnya dia adalah denominator lah. So you selesaikan. So b over exponent of b. You masukkan nilai b. So nilai b adalah infinity kat sini kan. So minus 0. So 0 over exponent 0, we have 0. Okay. So we solve for this one. We have infinity over infinity. Okay, so this one is indeterminate form. Then we need to apply L'Hopital's rule. Okay, so let our function here is s over exponent of x. Okay, so in L'Hopital's rule, we need to differentiate for numerator and denominator. So you differentiate respect to s on x, we have 1. Derivative respect to x on exponent of x, we have exponent of x. So we find the limit. So here we have 0. So 1, limit as approach to infinity for 1, we have 1. Limit as approach to infinity for exponent of x, it is infinity. So 1 over infinity is 0. Okay, so therefore the improper integral 1 minus x exponent negative s dx, where the interval here is 0 to infinity, it is equivalent with 0. So the limit exists, then the improper integral converge. Jelas? Ada soalan? Any question? Hello kelas, ada soalan? Tak ada. Faham eh?
Ish, aku tak tekan.
Apa dia?
Mina,
Yes.
kalau nilai dia tu kosong,
Ya.
negatif 1, boleh
Boleh?
ke? Oh, okey.
Alright. Okay, so untuk nilai kat bawah ni, yang last kali tu, it can be any value. Kalau you ada nilai negatif pun, kita dikira value jugalah. Dia ada limit lah. Maksud ada limit tu, dia ada boundaries. Okay, it has a boundary. Okay, so the improper integral converge. Dia kalau tak ada nilai tu, kalau you dapat infinity ataupun negative infinity, itu je. Okay, so if let's say we have infinity, then the limit does not exist sebab kita tak ada nilai. Kita tak ada nilai dia. Macam contoh yang mana tadi? Ada tak infinity? This one, infinity. We have infinity. So there is no value. So that's why we say that if we have infinity, the limit does not exist. So maknanya dia tak ada limit. Dia limit tu maksudnya dia ada boundaries kan. Kalau ada limit tu maksudnya dia ada boundary. Tapi kalau untuk macam ni dia tak ada limit. So kita katakan dia diverge lah. So the improper integral is always diverge. Okay. Faham ya? Alright. So ada soalan untuk example tu? Tak ada.
Tak ada.
Okay, very good. Okay, so next, example 3. So look at this example. Example 3, show that the area under the curve y is natural log of s over s squared. Okay, so infinite on the interval 1 to infinity. If so, state the area. Okay, so now, how to find the area under the curve? Macam mana nak dapatkan ni area? Keluasan di bawah lengkungan. How to find the area? Kalau kita nak cari apa tu? Kecerunan. Kecerunan apa dalam bahasa Inggeris? Gradient. Okay, if we want to find the gradient, so we need to use differentiation. Betul? Kenapa dia ada kaitan dengan differentiation? Kita tengok katakan you ada yang ini. Alright, and then we have this line. Okay, so we need to find the gradient. Kecerunan untuk yang ini. Yang ini ya. Kecerunan untuk garisan yang ini. Okay, so you perlukan nilai S dan juga Y. Okay, so this one, how to find this one? Kecerunan. M it is equals to y1 minus y0 over x1 minus x0. So kat sini you ada nilai katakan inilah y1, x1, y1. Point dia, kat sini. This one is about s1, y1, and this point it is about yx, not y0. Okay. So untuk cari M dekat sini, we need to find the differentiation between y1 and y0 over s1 and s0. Okay, kenapa kita nak cari differentiation? Kenapa nak cari different? Sebab dia berlaku perubahan di situ. Okay, so it is also equivalent with dy dx. Ataupun changes of y over changes of x. Right? So ini kan lagi nak cari keturunan. So now the question is how to find the area under the curve Y. Nak cari area. You ada area, you ada curve. Tak kisahlah curve ke line ke, you nak cari area bawah ni. Luasan bawah ni. Kita gunakan apa?
Integrate.
Kita guna integration. Okay. So this is the function of integration. Alright. So integration is used to find the area under the curve. Okay. Alright, good. So how to show the area under the curve? So area under the curve, this means that we need to find the integral of y with respect to x. Sebab y, it is depending on x. Dia bergantung kepada nilai x. And the values of x is 1 to infinity. So values of x 1 to infinity. Okay. So it is also equivalent with y. What is y? Y is natural log of x over x squared. Integrate respect to x, where x is 1 to infinity. Okay. So ini adalah area under the curve y. This one is the area under the curve y. Okay. Faham eh? Alright, so first of all, we need to check whether this curve, which is natural of s over s squared, it has this continuity in between this interval or not. Okay, so as usual, we check. So we have this function. So let f of x, function of s, natural log of s over s squared. Okay, so since s squared is the denominator, so s squared cannot be equal to 0. Okay, so based on this, x is not 0. Okay, so based on our checking, okay, we check discontinuity and then we check the interval. So the interval is about 1 to infinity. Okay, so based on this interval, 0 does not included in this interval. So that we can say that this curve, which is natural of x over s squared, is continuous on the interval 1 to infinity. Okay, so in other words, we can say that this function is defined for all values of x. So what values of x? Value of x is 1 to infinity. Okay, so kalau you masukkan nilai 1 dalam curve yang ni, dia akan memberi kita nilai, define. Okay, so there is no issue about discontinuity. Okay, faham ya? Alright, so next we solve the improper integral. So this is the area. Area is the integral of y dx, where x is 1 to infinity. So it is also equivalent with the integral of natural log of s over s squared, where x is 1 to infinity. Okay, so first of all, we solve for this integral itself, which is natural log of s over s squared. Integrate respect to x. So we focus on x. Using integration by parts, since it is involving two functions, natural log of x and x. Okay, so let u is natural log of x, and we differentiate, and here we have u equal to ds over x, and the rest is our dv. So dv is 1 over s squared. So integrate both sides, then we have v equal to negative 1 over x plus c. Okay, so we apply integration by parts formula, which is u dv equal to uv minus integral of v du. Okay, so at the end of the day, we have this answer. In negative natural log of x over x minus 1 over x plus c. Okay, so next, since the area involving infinite interval, okay, so here we can say that this is about improper integral, and then we need to use this definition to solve for this problem. Okay, so it is equivalent with limit b approach to infinity for the integral natural log of s over s squared, where x is 1 to b. Okay, so b is approaching to infinity. Okay, so you find the limit Alright, so here we have a negative limit b approach to infinity for negative natural of b over b minus 1 over b. Okay, so this one is lower limit, which is s equals to 1. So bila you masukkan kat sini, natural log 1 over 1, we have 0. Minus 1 over 1, we have 1. So that's why we have 0 minus 1. Yang ini. Okay, faham Alright. So next, we have limit b approach to infinity for natural of b over b minus with limit b approach to infinity for 1 over b minus you akan dapat plus. So limit b approach to infinity for 1. Okay. Alright, so untuk yang ini, you selesaikan, you dapat indeterminate form, which is infinity over infinity. So in the red box, it is how we solve for the first one, which is limit b approach to infinity for natural of b over b. Okay, so we apply L'Hopital's rule by differentiate numerator and denominator. So we have this one. So it just means that limit b approach to infinity for natural of b over b, it is equivalent with 0. Yang ini And then this one, limit b approach to infinity for 1 over b. Okay, b approaching to infinity, so we have 1 over infinity. So in limit, 1 over infinity is 0. So this one, it is approaching to 1 plus 1. So the answer here is 1. Right, so therefore, the area under the curve here is 1. Faham? So area dia adalah 1 lah, 1 unit. Okay, converge or diverge? Soalan dia tanya converge atau diverge kan? So converge or diverge?
Converse.
Converge because the
Ada
limit
value.
exists. Ya, betul. Okay. Alright, ada soalan untuk example 3. Tak ada? Tak ada
Tiada.
Okay, very good. Okay, so definition 3.2 type 1b. So type 1b, it is involving negative infinity to b. Okay. Right, so the improper integral of f over negative infinity to b is defined as improper integral in the left hand side. So we have this one, and in the right hand side, we have a limit a approach to negative infinity. Okay, for the integral f of x, where x is a to b. What is a? A is approaching to negative infinity. Okay, so the values of x, we can form it into this line number. Okay, so this is the upper limit b. Okay, so a, it is approaching to negative infinity. Okay, so this is a value of a. A is approaching to negative infinity. Okay, so negative infinity means that it is a lower limit. The lower limit lah. Sebab tu kita letakkan dia di bahagian lower limit. Ni lower, yang atas ni upper. Okay, faham ya? Okay. Okay, sama juga. If limit exists, then the improper integral converge. If the limit does not exist, the improper integral diverge. Okay. Right, untuk sebelum ni, sebelum kita discuss example 4, any question about the definition 3.2? Ada soalan?
Tiada.
Tiada Okay, so we take 2 minutes. Okay, can we continue? Kelas, boleh sambung?
Boleh,
Yes.
madam.
Boleh, madam.
Boleh, okay. Thank you. Alright, so next one, this one is about definition 3.2. So definition 3.2 is about type 1B. Okay, so look at this example. Alright, so example, evaluate the improper integral as exponent of x, where the interval of x is negative infinity to 0. Okay, so maknanya dekat sini, x is negative infinity to 0. So this is the interval for this integral. Alright. Okay, so look at this note. Since the integrand is not a rational expression, okay, so this is the key. Therefore, there is no necessity to test for discontinuities. Okay, so maknanya dekat sini, bila kita tengok integrand yang kat dalam ni ataupun function, dia tidak melibatkan apa-apa rule. Okay, apa maksudnya? So, kalau untuk rational expression, so rational expression is a ratio. So, ratio dia melibatkan rule di mana denominator tak boleh kosong. Okay, let's say kita ada function yang ini. We have A over B. The rule for rational expression here is P cannot be equal to 0. Okay, so that we need to check the discontinuity. Kita perlu check dia punya discontinuity. Tapi untuk yang ini, kita punya function adalah x exponent of x, which is there is no rule. Maknanya tiada apa-apa syarat. Which means x can be any real number. Okay, so x can be any real number. Okay, so kita tak perlu nak check dia punya discontinuity. Kalau you masuk nilai kosong pun dia mesti ada it define. Okay, so if we take 0, so 0 times exponent 0, we have 0. Okay, so 0 is value. Kalau dapat 0, dia define lah. Alright. Faham ya? Cuma kalau you plug in your calculator, you dapat math error. Itu maksudnya the function does not define, is undefined. Alright. Okay. So for this case, we do not need to check the discontinuity for the function. So the function here is as exponent of x. Okay. So based on this function, we can say that this function is continuous for all values of x. Okay. So what x as is any real number. Alright, so next we go to step 1. So step 1 we solve for the indefinite integral. So masuk indefinite integral, kita selesaikan untuk integral itu saja tanpa letakkan limit dekat dia. Okay, so for this case we use integration by parts. So we have this one. So solve integral x exponent of s dx. So let u here is x, so we differentiate, then we have du equal to dx. And the rest is our dv. So dv here is exponent x dx. So we need to integrate both sides. Then we have v equal to exponent of x plus c. Okay, so we apply integration by parts, which is integral u dv equal to uv minus integral of v du. Selesaikan yang ini. Then you akan dapat jawapan lah as exponent of x minus exponent of x plus c. Okay, so step 2, solve the improper integral. So based on the definition, for the improper integral, which involving negative infinity to 0, it is equivalent with limit b approach to negative infinity for the integral x exponent of s dx, where s is b to 0. So what the value of b? B is approaching to in negative infinity. Okay, so next we find the limit. So we have this one as exponent of x minus exponent of x with the limit 0 to b to 0. Limit dia pada bawah atas b to 0. Okay. So 0 is the upper limit. So we enter the value of x equal to 0. So we have 0, 0 times exponent 0, we have 0 minus exponent of 0. And then minus with the lower limit, b exponent of x exponent of x, we have b exponent of b minus exponent of b. Okay, so here we have infinity minus infinity. For the second part ni kita dapat infinity minus infinity. So this one is the first part. This one is second part. Upper limit minus with lower limit. Okay, so for the second part, we identified this about indeterminate difference. Okay, so indeterminate difference, we have about 3 steps. The first step, we need to combine the terms. Okay, so we combine from s exponent x minus exponent of x. So we have x minus 1 over exponent of negative x. Okay, so we find the limit. We have negative infinity to infinity over infinity. Okay, so next we need to apply L'Hopital's rule by differentiate for numerator and denominator. So after we apply L'Hopital's rule, we have limit as approach to negative infinity for 1 over negative exponent negative x. Okay, so we simplify inside here. Then here we have limit as approach to negative infinity for exponent of x. So find the limit, we have negative infinity. Okay, boleh? Okay, so that we can say that the improper integral as exponent s dx with the interval negative infinity to 0, it is equivalent with negative infinity. Okay, so the limit does not exist. Okay, so therefore, the improper integral diverge. Right? Boleh dapat? Kelas, ada soalan tak?
Tiada.
Tiada. Okay, very good. Okay, this one type 1C. Right, so type 1C, dia melibatkan negative infinity to infinity. Okay, right, so if we have this kind of problem, what we need to do here is we need to split it off into 2 terms. The first term, it is involving negative infinity, and the second term, it is involving positive infinity. Okay, so untuk C ni, you can take any number. You can take any real number. Katakan you nak ambil C equal to 0 pun boleh. Tak ada masalah. Alright. Okay, so next, from negative infinity to infinity, we split off into 2 parts. Then here we have integral f of s dx, where x here is negative infinity to C, plus integral f of x c to positive infinity. Okay, yang ini. Alright, so based on the definition, we have limit e approach to negative infinity for the integral f of x dx, where s is a to c, plus limit b approach to positive infinity for the integral f of x dx, where s is c to b. Okay, so in type 1c, it is a combination between the type 1a and 1b. Okay, the combination bagi type 1a dan juga 1b. Alright. Right, so we solve based on this definition, where C is any real number. So the improper integral is said converge if both terms converge and diverge if either terms diverge. So maknanya dekat sini, the improper integral will be converge if both are converge. Kalau salah satu diverge, maknanya the improper integral diverge. Okay, so first, second, katakan yang first tu adalah converge and combined with the second term will be converge. So therefore, the improper integral will be converge. Kalau yang first term converge, but the second term diverge, then the whole improper integral will be diverge. Let's say the first term, which is the lower limit negative infinity, diverge, and the second term, which is the upper limit here involving positive infinity, converge, then the whole improper integral will be diverge. Okay, so what happens if both diverge?
Diverge.
it no conclusion. Dia tak ada conclusion lah. Okay, we need to use other method. Okay. Alright, ada soalan? Tak ada. Okay, example 5. Yang ini saya sengaja tak nak buat solution sebab saya nak you yang buatkan solution je. Okay, so take it as your exercise. Okay, so evaluate the improper integral in type 1c for this function 1/1 plus x squared, where the interval of x is negative infinity to infinity. Okay, so x is a negative infinity to infinity. Okay, so first of all, we need to check this function, whether it has a discontinuity in between this interval or not. Okay, so let our function here is, I buat sikit nanti selebihnya you selesaikan exercise. Nak tahu you faham ke tidak? 1 plus x squared. Okay. So as usual, the denominator cannot be equal to 0. So 1 plus x squared does not equal to 0. Okay. So here we have x squared. Ni box sebelah sana, you akan dapat negative 1. So x does not equal to square root negative 1. Okay. So square root negative 1 ni apa? It is imaginary number. Okay, imaginary number. Okay, next. You look at this one, we check. So x is not imaginary number. Where in the interval, based on this, x is a real number. Okay, so x is any real number. Okay, so this means that imaginary number does not included in a real number. So imaginary adalah nombor yang selain daripada, bukan nombor selain daripada, nombor yang bukan real number lah. So real number ni nombor yang number tu adalah real number. Okay, termasuk apa real number? Termasuk integer, fraction and so on. Okay. So based on this, we can say that f of x is continuous on the interval on the interval negative infinity to infinity. Okay, so means that there is no issue about discontinuity. Alright. Faham? Faham tak?
Faham.
Faham Okay, so based on this, we can say that it is also equivalent with the integral 1/1 plus x squared dx, x negative infinity to c. So let's c equal to 0. So maknanya kat sini c tu you boleh ambil apa-apa saja nilai. Sebab x tu adalah this function is defined for all values of x. So apa saja nilai you masukkan dia sentiasa define. Alright. So next part it will be 0 to infinity. Okay, for the function 1/1 plus x squared dx. Okay. And then based on the definition, we have limit b approach to negative infinity for the integral of 1/1 plus x squared dx. Okay, b to 0. Okay. B is approaching to negative infinity. Plus with the second term, which is limit B approach to infinity for the integral 1/1 plus x squared dx, where x is 0 to B. Okay. So you selesaikan, solve lah yang ni. Selesaikan solve integral 1/1 plus x squared dx. So it is equivalent with tangent inverse of x plus c. Okay. Right. So therefore, limit b approach to negative infinity. For this one, it is a tangent inverse of x with the limit b to 0 and then plus limit B approach to infinity for tangent inverse of x with the limit b to 0. Okay, so next you need to identify for the first term converge or diverge. Sama juga dengan second term kat sini. If both converge, then we can say that the whole improper integral will be converge. Boleh buat? Cari nilai dia berapa? Okay, ada soalan tak? Improper integral. Tak ada?
Tiada.
Tak ada. Tak ada, bagus. So, kalau tak ada, kita lagi satu kelas kan? You boleh buat soalan textbooks. Improper integral. As a tutorial Hmm. Improper integral. Yang ini apa? Trigonometric substitution. Control F. Integral. Okay. Okay, so this is about quadratic factors in textbooks. Semana yang tak jelas dalam kelas, you boleh tengok dalam example in textbooks. Okay, dia lebih clear lah. Okay, so how repeated L'Hopital's rule and improper integral. Okay, so this one is about improper integral. Right, so soalan. You can skip. Integral. Okay, so ini semua L'Hopital's rule. So, you boleh tengok dalam ni banyak latihan you boleh buat Kita dah discuss ke untuk, kita dah buat latihan untuk L'Hopital's rule ke?
Tak ada.
Tak ada Okay, that's good. So, boleh buat soalan ni. Nineteen, 33, 44, 45, 59. Sekejap, I snapshot boleh tak? Screenshot. Print screen. Sekejap lagi nanti lepas kelas nanti saya screenshot and then saya bagi kat you all. Okay? Alright. Lagi exercise improper integral. Mana ni? Okay, so ini nota berkenaan improper integral in textbooks. Okay. This one, definition of improper integral. Alright. Ini pun example 2 in textbooks. So you can refer in textbooks. Definite infinite discontinuities. Ini pun ada juga. Okay. Right, nah ni soalan dia. Okay, yang ni pun nanti saya screenshot, saya akan share dengan you all. Alright, so make sure you buat. So untuk next class kita akan buat tutorial untuk kita buat improper integral dulu. Kalau sempat kita masuk yang indeterminate form tadi. Okay, boleh?
Boleh tu.
Okay.
Boleh.
Alright. Okay, ada soalan? Sebelum kita tamatkan kelas kita hari ini. Any question? Tak ada. Okay, so
Tempat
that's
ni
all.
tak ada.
Tak ada. Alright. Okay, that's all about chapter 2. Okay, so in chapter 2 we have discussed about indeterminate form and L'Hopital's rule, and the other one is this one, improper integral. Okay. Right, so kalau tak ada soalan, that's all for today. So class, thank you and Assalamualaikum. Right.
Thank you, madam.
You're
Thank you,
welcome.
madam.
Thank you, madam.
Thank you,
Thank you,
madam.
madam.
Sebelum you keluar, I nak ingatkan quiz kita hari Jumaat ni kita buat 1 jam je.